This demonstration is going to cover a structural design workflow for a building using AECOsim Building Designer, ProjectWise, and ISM as the BIM and collaboration platforms between the various disciplines on the project. Here's the building we're working on. It's a 3-story concrete framed hospital structure with a few different wings. And our task as the structural consultant, of course, is to produce construction drawings and other design documentation to the architect. So let's set the stage a little bit in terms of who and where the design teams are. My structural design team is entirely within one office. So we're happy to use a local server as the basis of our sharing of files and information. As we'll see, ISM will serve as the basis of coordination within our structural design office. The architect I'm working with, however, is on the other side of the world. So the structural architectural collaboration will require something fairly rigorous to ensure that the ongoing project progress maintains its integrity. The solution for this, as we'll see, will be provided by ProjectWise. Before we get into the details of how the workflow works with the software, I'd like to start with this conceptual flowchart here of how we're going to work. And that is that we start in the upper left-hand corner there by coordination with the architect, and we receive some starting point for a structural design from the architect, and an initial guess at the layout of the structural system. From there, we can essentially work our way clockwise around this flowchart. We can do a broad assessment of the structural configuration that was proposed, just to ensure that it's even within the realm of possibility. And then we can move on to more detailed structural analysis and design. Actually solve for the member forces, displacements, size the members, whether they be steel or concrete. In our case, this will be a concrete structure. Then we can move on to the design of components and connections, perform more advanced analysis if we need to, once we have a pretty good idea of what the structure is going to look like, the member proportions. Then we can get into what really our contract is all about, which is producing deliverables. We can go to the level of actually detailing the structure. Most likely, our work will culminate in the production of two-dimensional construction drawings. And we can repeat this process however many times we need to, with updates on the structure from the architect and giving the architect our input and our completed work as well. And at the center of this process, we have structural coordination, some means of ensuring that all the team members in our structural design team are in sync, are always have access to the most current state of the project. Okay. Now this whole process can also be expressed in terms of Bentley solutions. Okay. So we have a very similar flowchart now, except that in place of the concepts at each point, we have actual products. And each of these products perform that respective task. And at the top of this, of course, we have AECOsim Building Designer. And of course, AECOsim has tools for each discipline: architectural, mechanical, electrical, and structural. And since this is a structural workflow, we're going to emphasize the structural aspects of it. There's a few different, actually several different key features of AECOsim. I'm going to touch on the most important ones here. And the first is that you can model the entire building from scratch, model structural elements, give them intelligent structural attributes that can then be recognized downstream in the workflow by Bentley structural applications. The second one, very important in terms of the coordination with other disciplines, and that's that you can perform clash detection between any two entities in the model, resolution as well, and that'll give us a chance to see how we stack up against perhaps the HVAC layout that's been proposed, or other aspects, other disciplines versus the structural framing. The third item, of course, is generally what our deliverable is as structural engineers, and that's the ability to produce two-dimensional drawings from the 3D model. These can be customized as more or less any way the engineer wants. AECOsim has a very exhaustive set of customization tools that allow you to customize your drawings how you'd like. And finally, and this is the key point for the entire workflow process here, and that's interoperability with other structural products via something we call structural synchronizer, or ISM for short. It stands for Integrated Structural Modeling. And this is really what allows the information in the AECOsim model to be taken into the Bentley structural realm and further analysis of design performed on it. And at the center of this is Structural Synchronizer. And what is it exactly? Well, it's a framework that allows structural information in any Bentley model to be used by any Bentley structural design product. Okay? So basically it's a point of the data in any one Bentley model, structural model application, to be reused by any other Bentley structural application, essentially allowing you to start and stop at any two points in this process. And the way this actually plays out is that under the File menu of all Bentley structural applications, there are options to either create or read in an ISM model. And further, there's options to update along the way as well. Okay, but Structural Synchronizer is more than just a data transfer mechanism. It also allows you to track all the changes at any point in time that have been made to this master repository. Okay, who made the change, in which application, and when. And the fourth item here, one of the things that it gets for you is the ability to compare any 2 points in time of the state of the project. Okay. Further, you can roll back to an earlier state if things have gone wrong at some point and you've gotten off track, or if an earlier iteration on the design actually ends up being the choice made by the design team as to how to proceed. You can always roll back to that earlier version. And further, there's also compatibility with non-Bentley formats such as IFC, so you're certainly not stuck working exclusively in the Bentley world if you don't want to. Okay, so let's see how this actually plays out. Here's that hospital project I referenced that we're going to be working on. Okay. And as the starting point, before I start my actual structural work, I'm going to go over to ProjectWise. ProjectWise is the mechanism of collaboration between my structural design team and the architect that's over on the other side of the world. And the first thing I'm going to do is pull over the starting point that the architect has provided for me. Within ProjectWise, he's created a directory structure here for the project we're working on, and one of the folders is called Structural. And within that folder, he has placed a design model, a DGN model, that contains his initial attempt at the structural framing. He's also referenced in a couple of other layers that I'll need to coordinate with, and this is going to be my starting point. So what I've done here is I've actually pulled that design model from ProjectWise onto my local machine. I don't need to do that if I don't want to. I could easily work directly from ProjectWise, but here's my model. And now that I have it, I'm going to actually start my structural design work. Here's the full 3D model. Shown with all the levels on, mechanical, architectural, etc. And here's the references list. And these are all the different, all the additional levels that are included in this model. So what you see here is the structural framework, concrete slabs, beams, columns, walls. And the difference between these entities and the other ones that we saw is that these were modeled with the structural specific modeling tools within AECOsim. And that's very important because downstream in the workflow, these objects will be recognized by Structural Synchronizer, ISM, and therefore by other Bentley structural applications. And to just demonstrate some sort of cursory coordination that we could perform, I'm going to turn on the HVAC level down at the first story. And I'm going to do some clash detection between the structure and the HVAC level to see how what has been proposed fares. So over to the left-hand side, we have a tab, Coordination. Under that, you find Clash Detection. And this is a great feature for those of you not familiar with AECOsim to start with, because it's very simple to use, but it's also very powerful. So we have two sets of objects, two sets of clash criteria. I'm first going to create a job called Structural against HVAC. And as set A, I'm going to choose some specific structural levels. place the columns and the slabs, beams, etc., each on a different level. I'm just going to go through and select these beams, columns, slabs. And I'm going to pull these over into set A. And for set B, I'm just going to choose the HVAC level, which was referenced in. Okay, rather the referenced HVAC design model. And after I perform the clash, I see all the instances of clashes that occur here between these two. And I also see them drawn in the background. If I select one, I can go to the specific clash and get more information on it. And what we see, as I zoom in here, is that there's really two beams that are causing a lot of the problem. Okay, and since this geometry was chosen by the architect, it's just sort of an initial estimate. And I see that these two beams are causing a lot of problems. So what I'm going to do is I'm just going to go ahead and remove these and not count on them. See if I can get the design, the analysis and the design to work without them. And maybe since I've done that, I'll also make another change. I'll go ahead back out to the model here, and I'll thicken that slab here a little bit, since we removed some of the supporting elements. Change it from 150 mil up to 200. Now, of course, we can take this process further, different stories, bring in other references, perform further clash. But let's suppose that what we have now represents a pretty good starting point for our analysis and design, something we're pretty confident we can make work. What I'll do at this point is I'll create an ISM model from this AECOsim project. And again, at the left-hand side here, this will be a common theme throughout our workflow. There's ISM options, and this one is to export this to an ISM model. And you see that the ISM process here recognizes these elements. You can see them there in the list as structural. So I'm just going to give this a name. I'll name it the same as I've named my AECOsim model here. And I'll write that to ISM format. And when it's done, we will see a little notification down at the bottom that the export is complete. And so now I have an ISM model to work with and take further. So these were the first two steps we took. We did some cursory coordination in AECOsim, got to a point where we're confident, fairly confident that we can make the design work. And we wrote that to a structural synchronizer format. And now from here, we can read this format into the other applications that we're going to use in the process here.